So my talk about WebGL, but simple WebGL. WebGL that not make me hard, not make me sick, just WebGL to make something in two-dimensional art. Not WebGL that make three-dimensional art, not strong WebGL with strong mathematics. Just WebGL, simple as web, without GL. It's something like fun. My name is Korotaev Alexander. It's my funny Twitter handle, my GitHub, and I'm a front-end developer at Tinkoff. And also, I am one of organizers in SPB front-end community. Sometimes I help guys with something. And I'm a fanatic of game dev and something visual arts, creative coding, and etc. First of all, I want to tell you about my CFP list. It's a list of call for papers for conferences in Russia, in Belarus, in Ukraine, in Armenia. We have one conference. All of this conference can wants you with your Russian talks. Exactly on this meetup, it's not in topic, but if you, in some cases, you hate Russian talks, exactly, you can go to Helsinki and make English talk. These guys, 1 week ago, made a very warm welcome to me. And this guys invites you with your talks in English. It's nearby St. Petersburg. It's just 6 hours on the bus or free on train. It's not so, it's very close. But what about WebGL? As we've seen on the picture of 9 years of history of WebGL, we can see the WebAssembly have very big, amazing improvements, but WebGL is looks like it's slow. It's slower than WebAssembly in there. And it's only 2 versions of WebGL, and these 2 versions have not so big difference. And blazing fast and very interesting WebGPU technology, but unfortunately it's only in specification, it's only in papers. It's not only not realizations we have, but we're waiting for WebGPU because it's really interesting API. But unfortunately we need to live with WebGL. Why we need to live with WebGL? WebGL is a faster rendering engine is web. It means that all things that we draw it's faster than canvas, faster than DOM render, and something like that. But WebGL is, by concept, is too simple. It's just fast triangle rendering. All that it means that all that only thing that WebGL do it's render triangle. Render 1 triangle, 2 triangle, etc. Almost all that WebGL can draw, it's triangle. And we need to deal with matrices, with shaders to fill polygons between points. And in this case, it looks like abstraction, but we are just front-enders. We want to draw something beautiful, not triangles. And in this case, we need to go deeper but another way is go to find another path. And I want to show you another path. Looks like on typical WebGL code. Looks like this API is not from web. It looks weird and looks complex, and it's a port of OpenGL API for web. But not full port. You have found using this link differences between WebGL and OpenGL, and I can show about OpenGL have low opportunities than OpenGL, unfortunately. And but it's not so afraid, because almost all things that we have in OpenGL is just set state function, because OpenGL is we have with OpenGL we have global context, and we setting the state and mutating the state of this context, but we cannot get state. Unfortunately, we have no function to get a state, to check the state of our global context. We can only set this or manage it. And in this case, debugging of WebGL is annoying. Debugging of WebGL is a secret. It's not so good. And unfortunately, it's all that we have. But it's very, very faster. Exactly better better idea about why we cannot make a Canvas API with WebGL render. And I already tried to maintain library WebGL 2D that solves this problem, but unfortunately this library totally dead. I was maybe last maintainer of this library, and why dead? Unfortunately, many things that we already use in two-dimensional art cannot be applicable to WebGL. For example, rendering of text is slower. Rendering of many textures can be slower too in case of we cannot things as WebGL context works. And this case, this library dead because of it was slow because it's not make render faster without any changes in your code in case of you use just Canvas API, very simple API in difference with WebGL API. Exactly, triangles and something like that looks like these guys that really like to draw triangles too, and I start thinking about it's something like conspiracy theory for frontenders that nobody should understand WebGL, nobody. And in this case, I felt in depression about it maybe several times. About I never can understand how a WebGL works. I never can understand how to draw what I need using WebGL. Something except one triangle from many examples from internet. But we are front-enders. We can deeper in some technology, faster, deeper, and bring what we need and run away. Exactly, we can do that because we don't need all opportunities of WebGL. We need so teeny functions that can solve our problems. And first of all, it's pre-rendering. I start talking about some concepts that can reduce complexity of understanding of WebGL API. And it means that I try to not advise you to learn WebGL in deep. Just understand some typical cases to draw something on two-dimensional art. And what about pre-rendering? Pre-rendering, it's about render something and use it as a texture and in WebGL. I made some simple demo. Exactly 4 cases that demo not works. I made screenshot, but demo it works. No problem. Oh, it's so small. It's just canvas with WebGL effects. It's effects of blur. If I made more points, you can see the blur of these points. It's WebGL plus canvas. It's a too simple demo that makes that was a big picture. Is a very good picture for pre-rendering. I just make a texture on WebGL that was produced from Canvas. I render some stuff on Canvas and pass it to WebGL to make it faster. To start making an example like this, you just need to go to very good site webglfundamentals.org, and you have a lot of we have a lot of useful examples here. And you just don't need to learn this. You just need to copy this. And how we can copy it? We need to do something with pre-rendering. We just need to find some common picture drawing example using WebGL. We need to create our canvas, draw some picture on it, and after that we need to use our canvas as a texture on WebGL. It's pretty simple. Just copy the examples and make some modification of it. So, but we need to understand a couple of methods of WebGL context. So our highlights, it's texture creation. To make texture in the WebGL, exactly we need to create it. After that, we need to create a canvas, and we need to pass our canvas to WebGL context. WebGL context works with texture blocks. It's not a functional API like in different JavaScript or web APIs. We cannot get the state, we cannot get the current texture, we cannot operate with as an object. We just need to activate our texture in using texture block ID. For example, in WebGL it's GL texture 0, and we need 1, 2, and 20 texture IDs in WebGL. After that, we need to bind our space in memory for our texture that was created by GL create texture method. And after that, we need to pass our canvas to WebGL context to this activated texture block. It's maybe too complex to understand and after some JavaScript APIs that looks pretty nice, but unfortunately it's always that we have to render faster. And we need to make first shader. It means that WebGL is not about drawing, shader is about drawing. WebGL is all about prepare your data to pass it in your video driver, to pass it in your video memory. And shader is the main drawing instrument that you have. And in this case, the only technology that you want to learn to draw with WebGL in two-dimensional art, it's a WebGL. It's shaders language. It's a GLSL. It names GLSL. It's like a C, but simpler and with some common functions with a very good API to operate with the pixels, because this shader the shader runs for every pixel on the screen. And it means that we just need to use our texture as we need to pass our texture as a variable to our shader and use it to get color of pixel that we operate using shader. And what about more textures? Because exactly, if you can operate with one texture, we can operate with two or more, and we can make something like game using it. Because we can render all stuff using canvas, simple common canvas that many people know, and use it to make scene using merging of two textures that we produced by using canvas. And exactly we return with two well-known codes that just activate texture block and bin texture and pass the canvas to the WebGL context. And we need to learn something more about our WebGL context and how to connect it with JavaScript. To connect WebGL context with JavaScript, we use uniform variables that passes in shaders. As we seen already on the code sample in shader, we use first variable that what names U background. It's like in C language. Here we use different names. We can use any name of texture. And we need to pass location of it in video memory using WebGL functions like get uniform location. It's we need to get address from memory, from video memory to operate with it. So after that, we need to activate our texture block using a function that can pass some data to our uniform variables. It's uniform 1i. Its IP is so complex and sometimes names goes from the hell, I guess. But it just means that it means that this function can pass only strongly typed data to our video memory, exactly because video memory is strongly typed by memory. And we have a common functions list of maybe 20 functions with different names about different data types that pass to our shaders. And after that, we need to link our texture, bind it to our context using already well-known function active texture and bin texture. And as you see, we use different texture blocks for our textures. It's all that you need to prepare it. After that, we need to operate with it more simplest way. Just make something helper. Just make some helper for it. It's a function add texture that just stores texture locations from video memory and locations of attribute that we uniform attribute from video memory. And after that, we just push textures array, and it's all that we need. It needs to switch textures that we operate, because if you have 2 textures, 3 textures, 4 textures, we need to switch between them, because of video adapter can work only with 1 texture, only on one active texture. And in this case, we just need to pass texture variable from string null, 1, and something like that. Bind our texture, and we activate a texture block that we need. After that, we need to pass new canvas. It's a very important point, because unfortunately we cannot we cannot pass some data to video memory as in JavaScript using link data type. We cannot pass some object and mutate it. Exactly all data that already passed in video memory is immutatable. It's in this case, if you change something in canvas, we need to pass it again. It means that every frame that canvas redraw it, we need to pass it to our textures. We need to pass it in WebGL. In this case, code can help us. What about shaders? About shaders, we need to make another one uniform variable to store to operate with our texture, and after that we just plus one texture to another one texture. It's very simple. GLSL sometimes looks like a simple language for artists, because if we need to if you need to sum a summary to objects, we can. It's not JavaScript. It works. And how it works? I made some demo for them. It's just I need to make it something bigger. A lot of ununderstandable codes. But we can do something with it. For example, texture plus texture looks like this. Minus should works. Minus not works. Multiply works. Exactly, minus don't works. I don't know why. And division works too. And as you see, you have different results, and we just using simple mathematical operations to operate without textures. And we can deal with it. It's very simple, I guess. But I start for next demo. I want to tell you about something about shaders. Shaders is perfect. Shaders is good. Shaders is really interesting, because it's very fast. It's a blazing fast operations on your video memory, because shaders can operate in parallels, and it's blazing fast. And you can make effects over canvas to use to make your visualizations, to make your games better. I seen idea of how it works on one very good game. So let's make something. Enemies, where you are? Oh, we have enemies. This game has very simple canvas render. It's just polygons that draws to draw the enemies and some goals. but we have very good shaders that makes screen for them, that makes glitches and so on and so on. And this make games it's more pretty good. It's well better than just a canvas game, because we use WebGL for effects and canvas for drawing. It's a normal way to make two-dimensional games, two-dimensional visualizations in web, I guess. And what about script tag? As you've seen, I made demos for you, and you see the shaders goes from script tag. I guess it's not a good way, but on WebGL you can see a lot of examples that use a script tag that container for shaders. I guess it's weird. In our times, we can use Webpack and just go to npm, download raw loader and use it for shaders. Our shaders should be in code. And it's a better way to use shaders in your application in a web package. You don't need to use script tag. And to make something with shaders, I advise you to use WebGL utils library from webglfundamentals.org that makes all things better. To just operating for example, shaders. Create a program with a new entity for you, I guess, that makes your shaders work. To make entity, to make this program, to make entity, you need only two shaders: is vertex shaders and fragment shaders. We just only see into fragment shaders. Vertex shaders you just copy, not learn about how it works. You don't need it. And what about useful links for shaders? It's exactly a book of shaders. It's some basics that you should learn to understand how it works and how how we can make different effects using this. And exactly shader toy and GL sandbox. It's amazing sites that many people maintain, very perfect demos that works with glitches, some different effects, and sometimes some very crazy man can make big three-dimensional scenes just in shader. It's a big amount of GLSL code that I cannot understand how it works, and maybe these guys absolutely don't have free time, but I don't know how it works, but it's very good. Just click on this link after presentation, shader toy GL sandbox, and see examples. And what about my demos? For example, demo of my shooter game. To make it more understandable, I made 4 canvases for my game, and just on left corner you can see the result of working of shaders. Explosions, exactly, it's just canvas masks. I made masks on canvas and work with it on shaders and make some noise on mask to make it like explosion. And UI exactly, for UI exactly I have separate canvas that lean on top. It works better and it's not so hard to implement, but I spent something like 2 days to understand how to deal with it. So, but it's not all. For me, simplest way to use WebGL is using React plus WebGL, using JSX to draw something. It's amazingly simple. It's a simpler way to draw something on WebGL. It's a good way to draw a game for your job, and you need to make game on jobs like me sometimes. And exactly, you can go to Google and just Google React WebGL libs, but you can see only libs for three-dimensional art. Unfortunately, it's not so simple to understand, and I advise you those libraries that named React plus Pixie. One of them it's React Pixie, another one is React Pixie Fiber for some guys that likes Last React. And why Pixie.js? Pixie.js, it's a good rendering engine for web. It's a better rendering engine for web that I know. That's absolutely abstract you from WebGL or Canvas API to drawing because of it use WebGL, and in case of WebGL it didn't work, it used Canvas as a fallback. And it is very good things to learn, because you can use JSX with Pixie.js, and it's a very interesting experience for me, because this game was created just for maybe half of hour, and I cannot understand WebGL for them. That's hardest means of this presentation to solve something. Okay, it's hard to play. This all that we need to make game like this. This is just 6 lines of G6 code that makes all that we need. Exactly, these components draws primitives to make enemy, to make explosion, to make enemy. And it's pretty nice. It looks pretty nice. For example, everybody can read this code. Everybody can understand this code. And I don't know how much code I need to draw something like that, but using just Pixie.js API. I use JSX, not use Pixie.js API to drawing. It's better. And exactly better items from that. It's the full abstractions from complex WebGL API. It's a total reducing of complexity of WebGL API. But we have one problem with it. If you need to run setState function so fast, it can be not so fast. You need to go another way. For example, using first examples of this talk. But exactly, it's very good things for making prototypes, using to make WebGL games, true WebGL games. And as a final, I want to answer on some questions that we maybe have about rendering is truly faster. Renders became faster. I think yes or no, because in case of you need to re-render a lot of stuff, for example, if you have a lot of big texts, a lot of a big amount of texts on your game, in case of you need to render it, you can get a junk of your game. It's not so fast, and exactly. You don't need to use text on a lot of text on your game using WebGL, because text and WebGL is not so good friends, unfortunately. But what about effects? Unfortunately, required skill to you to make good effects using WebGL. It's a GLSL knowledge. Unfortunately, you don't understand anything. In case of you cannot go to book of shaders on some GLSL documents and read about how it works, because it's not understandable in difference with JavaScript for JavaScripters. And exactly, I really advise you to read book of shaders and go to sites with much more examples like GL Sandbox or Shader Toy. And this useful links for you. And this links for my presentation.
Any questions?
Hi, nice presentation. You said that it's hard to do text in WebGL, but applications that use OpenGL usually are pretty good with text, like browsers, for example.
Yeah, it's a different OpenGL. It's not a close WebGL. Unfortunately, we have a lot of hardware restrictions, and in this case, text rendering in hardware realized not the same as in web. For the web, at first you need to render your text in the canvas, the two-dimensional canvas, and render it as a texture in WebGL. Sometimes it's slow in some cases.
Okay.
Thank you. I'm learning WebGL too, and can we use WebGL in real life, in real projects? Because as I learn, WebGL allows us to that our applications can work faster because the code implement on video card. So maybe we can use WebGL in real projects, not in games.
As I remember, it's just only about mining of some crypto coins, but it's not. But it was unsuccessful, I guess. And sometimes some scientists use it to mine big data. But I guess better ways it's hardware for them than WebGL. WebGL is just for graphics. And, unfortunately, WebGL API looks like that only graphics API, and only thing they can you can make using it. It's manage pixels. It's a better way to use WebGL.
More questions?
Hi, thank you for your talk. It was great. And I have a question. Is WebGL fully compatible to Pixie.js? And can I use some snippets from that hardcore WebGL to that JSX React Pixie.js? So maybe import it and maybe use GLCL examples written by GLCL.
As I know, in Pixie.js you can use shaders. It's good. You can use shaders just in your code without any abstractions. But you cannot use samples from WebGL fundamentals because WebGL have global states, and exactly if you try to implement something besides state changing managed by Pixie.js, it looks like a shot in your leg.
Okay, thank you.
Thanks you. Thank you for your speech. I have a little personal question. As I know, in your work life, you're doing different things. I guess think of website and other. So my question is how to find balance between pet project, which is different from your working project. For example, if you have free time, what should you learn? Work-related skills or pet skills? How to find balance?
How to find balance? It's a strange, it's a weird question for me because I'm a fanatic of it, and sometimes I have no time for my wife. Sad story. And but last month, I guess, I started implementing games on my work, on my job, and it was my I really wanted to start making games on my job, and I started annoying to my employer about I want to make games on my job. I want to make games on my job, and after a couple of years, it started listening to me.
Thanks.
Anyway,
Thanks for the talk. I was just wondering if it's possible to use, maybe is it possible to use a video element as a source for texture?
Yeah, it's absolutely possible.
Oh, okay, great. So I can write shaders on video. Cool. Thanks.
Yeah, you can go to Shader Toy site, and as example, you can use video from examples of standard sandbox.
Thank you for your presentation. It's really great. Weird question. Can we expect that WebGL could become new Flash?
I don't know about it, but it's web technology. It's technology from web, but it looks like not like web. But I very I want to web GPU should be invented faster, because WebGL looks better than WebGL, but unfortunately graphics API is not discussed yet. Just API about how to get devices and use devices, different devices in functional style. It should be better than WebGL, but WebGL, it's all that we have to draw faster in web just now. We don't have another way.
What question is best?
Which one? Так. I need to remember how it's them. I like question about my life-work balance. Sorry, guys, with technical programs.
Okay, it's your dinner.
Because it's something private in my heart.
And now, вы меня простите, я перейду на русский.